Okay, this section we will be doing the quadratic formula. And so before we move into that, we're going to go ahead and do our bell work and we're going to review completing the square. So first of all, we're going to convert that number one, we're going to convert y equals 2x squared plus 8x minus 9 into vertex form by completing the square. So we're not going to use the axis of symmetry formula. This is a different method. This is what we learned last time. So first thing we're going to do is we're going to look at it and we notice that we don't have a 1x squared. We're supposed to have a 1x squared. So before we can fix that, we are going to separate the variables and the constant. So I'm leaving a gap and I'm going to move my -9 over here. Now I'm going to want that to be a 1x squared. So it looks like to me I can factor out a 2 out of the x squared and the 8x. And then I'm going to draw a line because that's where I'm going to put my c. And then I'm going to put another line because that's where I'm going to put the opposite of c. So remember to find c. So to find c, we take b, divide it by 2, and then we square it. So half of 4 is 2, and 2 squared is 4. Now remember, to keep the balance, what did we add? We added 2 times the 4. Anytime you have to have a number out in front, it's going to change what you're going to do to keep the balance. So 2 times 4 is 8, so that means I'm going to have to add a -8 on the end to keep the balance. Okay, so now we're going to write it as a binomial squared. And then a -9 plus a -8 is -17. And we are done. Stop. That's vertex form. We're not solving, we're just writing it in vertex form. Okay, the two below, we're going to continue and we're going to try to figure out what x is, but the one above was just to write it in vertex form. Okay, this one says solve by completing the square. So once again, I notice that 2x squared minus 12x plus 7. My x squared is not a 1. I'm going to have to fix that. But first, I'm going to separate my variables and my number, my constant. So I'm going to move, this time since I have it equal to 0 and I'm solving, I'm going to move the negative or the 7 to the other side and make it -7. Okay, now we're going to fix this problem of the x squared. It needs to be a 1x squared. So I'm going to factor out a 2. And then I'm going to figure out what c has to be to create a perfect square. Because remember, we're trying to get that binomial squared, and we want a perfect square trinomial. So we're going to take half of 6, which is 3, and square it, which is 9. But remember, anytime we put a number out in front, we're going to have to go 2 times 9. So 2 times 9 is 18. That's what we're going to have to add to keep the balance. Okay, now we're ready to write it as a binomial squared. And a -7 plus 18 is 11. And now we're going to continue to solve. And then we're going to go ahead and divide by 2. So we're going to have x subtract 3 quantity squared equals 11 divided by 2. And then we're going to take the square root of both sides. So x subtract 3 equals plus or minus the square root of, I'm going to actually separate that radical so we can see how we're going to rationalize that. That's going to be the square root of 11 over the square root of 12. So we need to rationalize that because we're not going to leave a square root in the bottom. So our final answer is going to be 3 plus or minus, and we're going to multiply top, numerator and denominator by root 2. And so we end up with square root of 22 over 2. So that's what we get for x on that one. So one on the right. Once again, I notice that I've got 3x squared minus 3x plus 8. I shouldn't have a 3 out in front. I needed that to be a 1x squared. So first thing I'm going to do before I fix that is I'm going to separate my variables. So 3x squared minus 3x. So I'm separating my variables from the constant, and I'm going to move the 8 to the other side. Now I'm going to factor out the 3 so that I can have a 1x squared. And now we're ready to find out what c is, the new c. So we're going to take half of 1. Well, half of 1 is a half. And when you take a half and square it, that's going to give you 1/4. Now, when I multiply 3 times a fourth, that's going to be 3/4. Okay, we're going to write that as our binomial squared. So how am I going to factor the 1/4? Remember, that was 1/2 times 1/2. So we're going to put each of those factors in each of the parentheses. So it's going to be minus 1/2 and minus 1/2. So that's going to be our binomial squared. And a -8 plus 3/4 is going to be a -29/4. You can get a common denominator, combine like terms, and you'll see that's what it is. Okay, now we're going to continue to solve this. So I'm going to divide by 3, and since I've already got a fraction on the right-hand side, remember, dividing by 3 is the same thing as multiplying by 1/3. So when you divide by 3, you're really putting the 3 in the denominator over here. So you've got x minus a half quantity squared equals a -29/12. So now we're ready to take the square root of both sides. And we get x minus 1/2 equals plus or minus the square root. I'll separate the radicals, a -29 over square root of 12. Okay, we're going to have to work on this radical over here. I'm going to add the 1/2. Now, first of all, it's a -29, square root of 29, so I know that's going to be an I. And then I also know that square root of 12 is 2√3. So now what I'm going to do is I'm going to rationalize that by multiplying top and bottom by √3. And we end up with x equals 1/2 plus or minus I square root of, and then 29 times 3 is 87 over, and then 2 times 3 is 6. So over 6 in the denominator. So there we go. We've solved both of those for x. Okay, so what we're going to do now, completing this, we're going to complete the square. Completing the square, remember, is just an algorithm. The first day I taught it, remember I gave you all those steps to follow? It's the same steps every time. So that's what we call an algorithm. So instead of actually having actual number values here, I'm going to go through it, but I'm going to have A, B, and C. So you can see what happens when we go through all the completing the square steps with a letter out in front. And that letter, of course, represents any number. So first thing, when I look at that ax squared plus bx plus c, I'm going to separate my variables from my constants. So I'm going to write it as ax squared plus bx equals -c. Okay, now ax squared, that doesn't necessarily have to be a 1. A doesn't necessarily have to be a 1. So we need to create it so that it is a 1. So we need to factor out an a. Well, how do you factor out an a from a b? Well, basically, remember when you're factoring out, you're dividing those terms. So what do I mean by that? When I factor out an a, I'm going to have x squared plus b divided by a times x. Okay, let's take a minute and actually decide if you did the distributive property and you took a and multiplied it by b times a, so if I took this and multiplied it over here, would I end up with b? Because that's what I had before. Yeah, you would, because the a would reduce and you'd end up with b. So that's the right middle term. Looks really hard, but that's what it is. It's b divided by a. Okay, so now remember to find our new c. We have a c there already, but we're supposed to always create a new c, remember? So to do that, we always take the middle term. So here's my middle term. We divide it by 2, so we cut it in half, and then we square it. So if I square that, that turns out to be b squared over 4a squared. So that's what's supposed to go in this spot right here. B squared over 4a squared. Okay, now to keep the balance, I have to multiply this a times this. So if I take b squared over 4a squared and I multiply it by a, then one of those a's is going to reduce with one in the bottom, and we're going to end up with b squared over 4a. That's what I'm going to add right here, b squared over 4a. Okay, just follow, just watch with me for a minute. Now, on the right-hand side, since I have a negative c plus b squared over 4a, I want to get a common denominator. So my common denominator is 4 over a. Now remember, if I want to get a common denominator with this c right here, we need to have that denominator be 4 over a. So that means I'd have to multiply the top times 4 over a. That's how I get a common denominator. So that's going to turn out to be a negative 4a, and then I'm going to times it by that c, and then plus b squared over 4a. Okay, that was getting a common denominator. Okay, I'm going to kind of just rewrite it, and I'm going to just put the b squared first. So I'm going to go b squared minus 4ac divided by 4a. Okay, that's kind of reducing the right-hand side. So the left-hand side, we were supposed to write that as a binomial squared. So we have the a out in front, and then we've got to have x plus, and then this is going to be b over 2a quantity squared. Because remember, we're going to split that b squared, 4a squared into 2 equal parts to get our binomial squared. Okay, now we're going to have to divide by the a. Well, we already have a fraction, so we're going to have x plus b over 2a quantity squared, and I'm dividing this a right here, that a right here to the other side. So that's going to be b squared minus 4ac. I already have a 4a in the denominator, so when I divide this a over here, it's going to multiply, so I'm going to have 4a squared. Okay, this looks really complicated, I know. Just hang with me, we're almost done. Now we're going to take the square root of both sides. And we're going to end up with x plus b over 2a equals plus or minus, and I'm going to put this into two different radicals so we can kind of see how it reduces, b squared minus 4ac over the square root of 4a squared. All right. I'm going to move this opposite of b over 2a to the other side. I hope somebody's recognizing opposite of b over 2a as some important formula that we knew about earlier in the chapter. And then we're going to have b squared minus 4ac. But then in the denominator, the square root of 4 is 2, and the square root of a squared is a, so that's what I have. Notice I ended up with a common denominator, so I'm going to write that as x equals the opposite of b plus or minus b squared minus 4ac over 2a. And voila, that is the quadratic formula. So you might be thinking, oh my gosh, I can't do that every time. Well, yeah, the nice thing about the quadratic formula is now you don't have to complete the square every time. You don't have to go through those steps. It's an algorithm, and when you go through the algorithm, the numbers relate to each other in this final pattern. So the nice thing about it is now we can just go straight from the original quadratic to the quadratic formula. We can skip all of the steps in between of completing the square. So this slide right here is just a bunch of fun YouTube videos you can watch if you want. It's just different songs to help you remember the quadratic formula, to help you memorize it. So here we go. That's the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. Where, when you are working with the quadratic formula, a, b, and c come from your quadratic, and that's what you substitute into the formula. So c goes here, b goes in these two spots, and a goes in those two spots. So now you don't have to complete the square. You can just, it's just plug and chug is what you do. You just plug the numbers in and figure out the answer. So here we go. We've got 3x squared plus 3x minus 2. So first thing you want to do is get it equal to 0. And always check to see, because remember, we're solving a quadratic. So now in our toolbox for solving quadratics, we know how to factor. We have the technique of taking the square root of both sides. We have completing the square, but I think I'm going to change completing the square. Unless I'm writing it in vertex form, I'm probably not going to complete the square anymore. I'm just going to jump straight to the quadratic formula. So I've got these three methods to help me solve a quadratic. So this x squared plus 3x minus 2, when I get it equal to 0, I can see that it won't factor. Because of this negative sign on the end, there's no way to get a 3. That means I'm supposed to subtract the factors of 2 to get a 3. That's not going to happen. So factoring is out. So can I take the square root of both sides? No, I can't. The only way we can do the square root of both sides is if you have an x squared only, or a binomial squared. I don't have that. I've got an x squared and an x. So that leaves me with quadratic formula. So now you just have to identify the a, b, and the c. So a is right here out in front. Here's my a. This is the b, and this is the c. So a is 1, b is 3, and c is -2. Okay, so we're going to actually substitute the numbers in the quadratic formula. So quadratic formula says, take the opposite, right here, first step, take the opposite of b. B is a +3, so opposite would be -3. Plus or minus. Now I'm supposed to take b and square it. Well, I'm going to do that in my head. B squared is, 3 squared is 9. This number right here, guys, this b squared that we just found, should always be a positive number. Anytime you square a number, it will be positive. So if you've typed it into your calculator and you got a negative number, you did it wrong. That should always be a positive number. You're squaring. Okay, then we're going to subtract 4. And then it says to put a in, right here. A is 1. And then I'm supposed to put c in. Well, c is -2, so I'm going to put -2 right here. All divided by 2 times a. And remember, a was 1. Now, when you use this on your calculator, guys, different calculators do different things. So how I want you to do this is I don't want you to type in the radical symbol when you're working on your calculator. If you're going to go to your calculator, I just want you to figure out what this number is right here without the square root symbol. I should know what that number is before you type in a square root symbol. So you would say 9, you could type it straight in your calculator if you wanted. 9 subtract 4 times 1 times -2 is going to give me 17. I want to be able to see that number right there, guys. And then 2 times 1 is 2. And now we're done. That's it. X equals -3 plus or minus the square root of 17 divided by 2. That's the exact same answer we would have gotten if we would have went through all the steps of completing the square. So what is this telling you guys? The nice, I kind of highlighted the idea about the axis of symmetry. This -3/2 is your axis of symmetry. That's your opposite of b over 2a. So now this square root of 17 over 2, what is it doing? Well, this is what it's doing, guys. If your axis of symmetry is at, let's just kind of make a sketch here. If your axis of symmetry is at a -3 over 2, so that's a -1.5. There's your axis of symmetry. Okay, what it's telling you to do is now add the square root of 17 over 2 to that. So if I take the square root of 17 over 2, I'm going to get a decimal approximation for that. That is about 2.06. So if I go right here and I add 2.06, that would move me to the right. So here's 1, and here would be about 2. It'd put me about right here. That's one of my zeros. Now, and then the other one says take negative 3 over 2 and then subtract the square root of 17 over 2. Well, then I would be subtracting a negative 2.6, so that would put me about right here. And there's my other 0. There's my other x-intercept. So these are our x-intercepts, and it's kind of nice because we can see right here how that relates to the axis of symmetry. Here's your axis of symmetry. You go right so much, you go left so much, and you get your other intercepts. So that's the nice thing about the quadratic formula. It kind of ties the two zeros together from the axis of symmetry. Okay, so here we go. Here's another one. This says 25x squared minus 18x equals 12x minus 9. My first thought is it's a quadratic, so I need to put it equal to 0. Before I start any method, I'm going to have to put it equal to 0. So 25x squared, subtract your 12x, and that's going to give you a negative 30x. And then I'm going to add 9, and that's going to equal 0. Now, if you could get that to factor, I would probably factor it. This one does factor. You end up with 5x and 5x and 3, a negative, negative. So it turns out x equals 3/5. Okay, well, that's what I would do. I'm going to go through the quadratic formula so you can see what happens. It's kind of important to see what happens under the square root symbol if it factors. So here we go. We're going to go ahead and I only got one answer here, right? X is 3/5. It's the same answer twice. So I'm going to go ahead and put it in the quadratic formula so we can see how it works out with that. So if I do opposite of b, that's going to be 30 plus or minus b squared. So 30 squared is going to be 900 minus 4 times a is 25, times c, which is 9, divided by 2 times a. So 2 times 25. So x equals 30 plus or minus. I'm going to draw my square root symbol, and now I'm going to figure out what is the number underneath the radical. Well, that's 900 minus 4 times 25 times 9. That turns out to be 0. And then 2 divided by 25 is 50. So look what happened. We got a 0 under our radical. And so we ended up with x equals 30 over 50. And then that reduces to 3/5. Okay, let me backtrack over here when we were talking about, let's go back to that other example when we drew that sketch of our zeros and the axis of symmetry. Our parabola would probably be looking something like this, right? It opens up. We have two x-intercepts there. What happens here when you only get an x equal to 3/5? Well, if you were going to make a sketch of that, what's happening is, here's 1, 3/5 is right here. You only have 1, 0, so your vertex is actually sitting on the x-axis. So your parabola looks something like that. You only have one solution, so the vertex is on the x-axis. Okay, let's try it again. So here we go. We've got a negative x squared plus 4x equals 5. And I'm going to put it in the quadratic formula. Now, I notice a lot of you guys would probably put the negative 5 over with the negative x squared, but I always want a factor. That's always my first choice. So in factoring, I want it to be a plus x squared. So I'm actually going to move these two to the right. So that's going to give me x squared minus 4x plus 5 equal to 0. Now, that won't factor, unfortunately, but I always want to check to see if it will. I like factoring. For me, it's quick, it's easy. I like it. But it doesn't work, so now I'm going to go to the quadratic formula. So x equals opposite of b. So right now, b is negative 4, so the opposite of that would be positive 4, plus or minus the square root of b squared. So that's 16 minus 4 times a times c, c is 5, divided by 2 times a. So then our next step is just to figure out on your calculator without the square root symbol. Do not type the square root symbol in. Figure out what is the number underneath the radical. That would be 16 minus 4 times 1 times 5. So that's a negative 4 divided by 2. So x equals 4 plus or minus, now the square root of negative 4 is 2i divided by 2. Now this is what I call the triangle right here. That 2 has got to see how it kind of makes a triangle. That 2's got to divide into both of those numbers, and it does. So I'm going to go ahead and reduce that to 2 plus or minus 1i. Okay, so how does that relate to a parabola or a solution if that's a quadratic? Well, we talked about this earlier, remember, if you get I answers when you're solving a quadratic, that means there's no x-intercepts. So something is happening here with our parabola in that our vertex is sitting above, in this scenario, it's sitting above the x-axis, and it's opening up. My y-intercept's a plus 5, so it's just kind of opening up. So there's no x-intercepts. I know that by the fact that I got an imaginary answer. Okay, one more. 4x squared minus 10x equals 2x minus 6. So once again, I always want to see if I can factor first. So I'm going to combine all my like terms, put it equal to 0. So 4x squared minus 12x plus 6 equals 0. I move this one to the left and that one to the left of the equal sign. And I notice that there's a GCF, so I'm going to take the GCF out. It's a 2. So 2x squared minus 6x plus 3 equals 0. Now, if 2x squared minus 6x plus 3 equals 0, I'm going to factor that. Let's see, can we get that to factor? If I put a 2 here and here, a 3, and a 1, that's going to give me a 7, right? Because I'm going to add those two together. So if I go the other way and I put the 3 here and the 1 on the right, it's going to give me a negative 5. So unfortunately, it doesn't factor. But the nice thing about that step, though, is when I go to the quadratic formula, I don't use the original formula. If you take a GCF out, guys, and you want to go to the quadratic formula after that, this is now your A, this number is now your B, and this number is now your C. That's really nice because it keeps the number smaller. That's the nice thing about taking out the GCF. If you take the GCF out first, you get to work with smaller numbers. And smaller numbers are always easier to do mentally. So you're going to want to use 2, negative 6, and 3 in the quadratic formula, not 4, negative 12, and 6. Okay, so quadratic formula says take the opposite of b, plus or minus b squared, so a negative 6 squared is 36, so I'm going to write that down, minus 4 times a times c, and that's all divided by 2 times a. Okay, so let's reduce that. So 6 plus or minus, and remember you want to just figure out what is the number under the radical without the square root symbol. So 36 minus 4 times 2 times 3 equals 12 over 4. All right, so now I'm going to reduce my radical. So that's going to be 6 plus or minus 2 root 3 over 4. Okay, we want to take a look here. 4 is supposed to divide into those. There's our triangle. 4 doesn't divide into those, but I notice that they are all divisible by the same number. They're all divisible by 2, so I think I'm just going to reduce them all by 2. 3 plus the square root of 3 over 2. There's our answer right there, plus or minus. Sorry, I forgot the minus. 3 plus or minus root 3 divided by 2. So what would that look like? It would look like you would have 2 zeros on the x-axis, and you probably would be opening up. That's kind of what's happening there. You got 2 real solutions for your answer. Okay, So here's a fancy word. This word shows up when you're taking the ACT. It's kind of a really important vocabulary word, and it's called the discriminant. And the discriminant is a very specific part of the quadratic formula. It is the part where we just type in the number without the radical, just b squared minus 4ac. That's called the discriminant. And the nice thing about the discriminant is you don't have to do the whole problem to figure out what kind of answer you're getting. So if you go back and look at what happened here, I kind of picked very specific problems so you could see what happened. When our discriminant was greater than 0, so when we ended up with a positive number, let's go look at all of our problems here. When our discriminant, this one right here is the discriminant, it's a 3, that's a positive number. Look, we had 2 zeros. Let's go back here. What did we get underneath here? Oh, discriminant was a -4. That was not positive. Discriminant on that, 0. Nope. Discriminant here was 17. That's a positive number, and we had 2 zeros. So that's what it's telling you. If your discriminant ends up being a positive number, then you have 2 real zeros. Okay, what happened when the discriminant was less than 0? When it was a negative number? Well, we had one of those scenarios. What happened? Let's go find it. Here's the discriminant right here. It was a negative number right there, -4. What did we end up with for an answer? We ended up with an I for an answer, which let us know that we didn't have real solutions. So back here, we ended up with 2 imaginary solutions. So when that number was negative, and then what happened when it was equal to 0? We did that scenario. When it was equal to 0, oh, I went too far. Where did it go? Right here. When it was equal to 0, right here, we ended up with 1 real 0. We ended up with it just sitting on the x-axis. That's what the discriminant's telling you. So we have all of those different scenarios right there of what happens when the number under the radical, that's what the b squared minus 4ac is, that's your discriminant, that's the vocabulary word. When it's positive, you get 2 real solutions. When it's negative, you get 2 imaginary solutions. And when it equals 0, you get 1 real solution. So discriminant is an important vocabulary word. You need to know that. And it's just the number that you would get without the square root symbol, the b squared minus 4ac. That's what the discriminant is. Okay, now we know how to use the quadratic formula, and it's really nice. So honestly, guys, when I'm asked to solve a quadratic, usually what I think first is factor, and now I usually jump to quadratic formula. So if it can't factor, I try to do the quadratic formula. And then if I have to, I'll do the square root technique. But I kind of choose factoring and quadratic formula as my most popular ways to solve a quadratic.